As definitions become cloudy, the individuality of electric concept goes along with it. What the definitions really give to us and how to understand them. Results show a large misconception by the masses on what EPE is. Its full breakdown tackled later. Later, we'll be joined by Danny No, local expert, to discuss what sets electric potential and electric potential difference apart and why it matters to know.
Good evening, Physics World. We begin our evening with sources showing that the class's ability to retain information has dwindled in the last 3 months and have therefore forgotten previous topics. Here is Ibrahim Fernandez on the field to catch us up. Ms. Ibrahim?
Good evening. This is Ibrahim Fernandez reporting live from the electric field, electric potential energy, and electric potential difference, and many more electric-related words are charging through the people's electricity. Where are they now? How are they doing? And most important, what do those words even mean? The electric words are reported to have been spotted inside the electric field where we are now. Electric field is a vector space that surrounds electrically charged particles such as protons and electrons. Electric field lines are imaginary curved lines drawn for us to help better visualize where the direction of the electric field is going. Me and the team had found it quite hard to walk along the electric field because one would need enough electric potential to do so. Electric potential is the amount of work or energy needed per unit of an electric charge at a given point here in the electric field. As it stands, the said electric charge is capable of storing electric potential energy. Electric potential energy is the energy stored in a system of electric charges due to their positions in the electric field. And that is all for, Oh, excuse me. It looks like there's been a sighting of an electric charge moving just now. Breaking news lands. An electric charge moves from one point to another. It creates what is called the electric potential difference. And this difference between 2 points is also known as voltage. It represents the work done to move a unit positive charge from one point to another in an electric field. And as of this moment, it seems that the electric charge had just finished moving. Reporting live from the electric field, this is Ibrahim Fernandez on P69 tonight. Stay tuned for more updates.
Thank you for such a wonderful recap, Ms. Ibrahim. In this fast-paced semester, topic after topic after topic, it doesn't hurt to let our brains take a step back and refresh itself on what it should know. Let us join Mr. Leonard de Dividad in remembering the concept of electric potential energy and jump-starting our thinking juices back to full power. Leonard?
Thank you, Mr. Kyle. We're reporting live the electric potential energy and the hidden energy stored between charged objects. Without any further ado, let's break it down. Electric potential energy is the energy a charge has because of its position in an electric field. Additionally, EPE measures how much energy is stored or released when two charges interact. The formula depends on the charge size, their distance, and to the Coulomb constant. The basic idea is if you have two charges and you move one closer to the other, you either have to do the work or they will pull naturally. Let's take into example.
Let's say we have two charged balloons, one with negative 5.23 times 10 raised to negative 7 Coulomb, and the other is negative 6.77 times 10 raised to negative 7 Coulomb. They are 20 centimeters apart. What is their EPE? Let's say our Q1 is negative 5.23 and Q2 is negative 6.77. Using Coulomb's constant and their distance apart, we can use the EPE formula. By substitution and simplification, we will have 15,933 microjoules. Since the EP is positive and decrease with distance, the balloons will repel to move apart and reduce their potential energy. Now, what if our balloons are oppositely charged? One with 6.55 times 10 raised to negative 7 coulomb, and the other balloon is negative 3.72 times 10 raised to negative 7 coulomb. And this time, they are 31 centimeters apart. What's their EPE? Using the same formula from earlier, we will get the value negative 7,074 times 10 raised to negative 6 joules, or simply microjoules. The negative EPE means they attract. Energy is released as they pull together. That's why the balloon sticks.
In short, positive EPE is equals to repulsion, and negative EPE is attraction. Remember folks, whether it's sparks or static, EPE is the VIP, the very invisible power, behind the push and pull of our electrified world. Stay charged and stay curious. Back to you, Kyle.
What a wonderful exposition, Mr. Leonard. For tonight, we have two more heavy words left to tackle. Who else but our local expert, Mr. Danny No, be fit to explain them? Mr. No?
Good weather we're having, Mr. Kyle Bunoy. Here live, we're diving into a fascinating topic that powers the very world around us. The difference between electric potential and electric potential difference. First, let's start simple. Imagine you are standing on a hill. Your height above the ground indicates your gravitational potential in the field of electricity, and a similar concept exists called electric potential. Electric potential is a measure of how much electric potential energy a single charge has at a given point. Similar to your energy at a certain height, it's measured in volts.
But what really matters is the difference. The electric potential difference, also known as voltage, is the difference in height between 2 points on that hill. Change causes things to move. In circuits, the potential difference between 2 points causes electric changes to flow, powering our homes, cars, and even this broadcast.
Let's do a little setup first. Consider this. Our point charge is positive, so Q equals positive 3C, located at the origin, and we want to calculate the electric potential and the electric potential difference between 2 points. So, one at 4 meters away from the charge and the other at 6 meters away. So then, we'll calculate the electric potential at both of these points and then find the electric potential difference between them.
Let's start with the electric potential at point 1, which is the distance of 4 meters from the charge. We use this formula for electric potential at a distance r from a point charge. V equals kq over r. Here, k is Coulomb's constant, q is the charge, and r is the distance from the charge to the point where we're measuring the potential. Now let's plug in the values for V1. So at point 1, the electric potential is approximately 6,742.5 volts. Now, let's calculate the electric potential at point 2, which is 6 meters away from the charge. We'll use the same formula, but this time with R2 is equals to 6M. At point 2, the electric potential is about 4,495 volts. Now, the next part of our problem, let's find the electric potential difference between 2 points, which is point 1 and point 2. We use this formula, which is V equals V sub 2 minus V sub 1. The electric potential difference between these 2 points is negative 2,247.5 volts.
The negative sign indicates that the potential at point 2 is lower, farther away from the charge. So, if you move a positive test charge from point 1 to point 2, it will lose potential energy. So, when the potential difference is positive, it means that the potential at point 1 is higher than at point 2. In this case, if you move a positive test charge from point 1 to point 2, the charge will gain potential energy. To summarize, electric potential explains how energy is stored at a point, and the electric potential difference drives the movement of a charge, which powers the world around us. These concepts underpin everything from your phone to electric vehicles and critical hospitals equipment. And that's about to wrap it up. I'm bringing you back to Mr. Calbunoy. Mr. Calbunoy,
Thanks for the fun lesson and insight, Mr. Field Expert Dan, That definitely jogged my memory of our previous lessons. Well, folks, it seems that that's everything we have for tonight. I hope this evening has been very informative for the new and the experienced alike. I'm your host, Calpushin G. Bunoy. Meet us back here, same time, same channel tomorrow. Twisting everything, even time zones, but not the truth. This is P69, tonight.